So I hope everyone can see my screen. Please, if you can, let me know so I can go on. Can we see my screen?
Yes, sir.
Okay,
Can see it, sir.
okay, good. So from the last section we had, which was the first section, we spoke about um, statistics, where we were talking about the introduction to statistics. We literally spoke about some the definition of statistics, how we get to use statistics, and how does statistics come in handy for us as data analysts. So now this section will be talking about um, descriptive statistics. Before we do that, we'll also still get to see the definition of statistics, while other sections will be taken by different tutors. So, but then giving us the process of how we will get to learn is how we are going through in the section. So, when we talk about statistics, we said introduction to statistics. What is statistics? And last class, I gave this definition that says that statistics is the science of collecting, analyzing, interpreting, and presenting data to help us understand patterns, make decisions, and draw meaningful conclusions about the world around us. So, in simpler terms, we say statistics is like a toolbox that help us make sense of numbers and information. It allows us to make large amount of data and turn them into useful insights that can guide our choices and help us better understand various aspects of life, from business and science to everyday decision. What do I mean? What am I trying to say? We have access to some a particular like a toolbox that which is that of statistics that can help us make sense out of number. I'm sure while we were in lower grades, like in terms of schools, when they were teaching us about mean, media, mode, we're all thinking, oh, they just want us to put formulas in our head. But actually, we were using these particular formulas that we think they are putting in our head to actually get insights. But then we were just trying to make sure, we pass our assignments, pass exams and all. But in this class, we'll be getting to see how this thing gets to influence some of the decisions we are going to be making in terms of data. Most of the time we say, well, as a data analyst, you have to make data driven decisions. Decisions by making sure you are creating or you are analyzing the data to what to pass out informations that can help businesses grow. So that's why I was saying that in a simpler term, statistics is like a toolbox that help us make sense of numbers and information. It allows us to make large amount of data and turn them into useful insights that can guide our choices and help us better understand various aspects of life, from businesses and science to everyday decision. So now, moving on, work with me. Type of statistics. We say statistics are being majorly categorized into two types. Statistics are being majorly categorized into two types, which is descriptive statistics, inferential statistics. In this class, I will be focusing more on descriptive statistics. So you could see, let me try and let this person in and then. So statistics has been majorly categorized into two types, which is descriptive statistics and inferential statistics. In this class, we are going to be mainly focusing on descriptive statistics. You can see from the image here, I have my type of statistic, which is talking about descriptive statistics, inferential statistics. Now, under descriptive statistics, we now have something called what measure of central tendency, which is what mean, mode, media. We now have measure of variability, which is what range, variance, and dispersion. When we're saying dispersion, we're still trying to talk about standard deviation, talking about interquartile range. When we have knowledge of this particular of this descriptive statistics, we get to understand that there are some things we can know from our data that can make us get to do a very good analysis. So when from their words, measures of center tendency, measures of variability. Now we will go deep into all these words where we start to see what mean is all about, what mode is all about, what media is all about, what range is all about, what variance is all about, what dispersion is all about. But now in a descriptive statistic, we want to look at the measure of central tendency. But let's see what descriptive statistics is all about. Moving on, we say descriptive statistics. Descriptive statistics. What is descriptive statistics? Descriptive statistics are techniques used to summarize and describe the main feature of a data set. We use it to do what? Summarize and describe the main features of a what? Of a data set. So from the image here, you see it says it again. It's statistics that summarize or describes features of a what? Data set, such as its central tendency or dispersion. So when you're talking about descriptive statistics, what we are really focused on or what we are focusing on is what? Is central tendency or dispersion. Now, we said furtherly, in descriptive statistics, we describe our data in some manners and present it meaningfully so that it can be what? Easily understood. So they help us understand what? The central tendencies of our data, how spread out our data is, the shape and distribution of our data. So when you're saying the central tendency of our data, we're talking about you using functions like mean, media, and mode. And when you use these functions, they help you, get to figure out things about outlier, skewness, symmetric, about the data you have. And when you're talking about spread out of our data, we're talking about how our data is spread out and find the shape and distribution of our data. So now, moving away from descriptive statistics, now let's get to see what central tendency is. Measure of central tendency. When we say measure of central tendency, we say the measure of central tendency tell us about the typical or central values in our data set. So just like we're saying, when you talk about descriptive statistics, what are you trying to talk about? There are two things under this descriptive statistic: measure of central tendency, or what? Measure of variability. So now, going deep into the measure of central tendency, what are we trying to say? It also represents the whole set of data by a single value. It represents the whole set of data by a what? A single value in terms of what? Mean, mode, media. I can have a whole data set now and I want to understand what is going on between, in this data set. And I say I want to find the mean. Obviously, by the time I get the mean, I'm literally going to get a single value. But then it's going to give us the location of the central point. That is exactly what the mean, the mode, and the media is going to help us all about. And in this class today, we're going to be looking extensively into mean, mode, and media and how they tend to help us get the location of our what? Central point. Work with me. Let's look at mean. We said there are three main measures of central tendency. We're saying the mean, media, and mode, just as it is in this um, diagram that we have here. Now let's look at what mean is. When we say mean, a lot of us hear mean, a lot of us hear average. We're still talking about the same thing. We want you to find the average. So when you say average, you're saying that, or the mean you're saying, is the sum of observation divided by the what? Total number of observation. I have an observation of 10. Now I add those 10 together. That is the sum of observation. I divide it by the total number of observation, which is what? 10 observation. So when I add 1 to 10, I know that when I'm adding 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 all together, it gives me a particular value. Now I need to divide it by the total number of observation. How many numbers do I have? 10, which will give me what? The mean. And from here is also defined as average, which is the sum divided by what? Count. Just as I have said, it is defined as what? Average, which is what? The sum divided by what? By count. From the formula here, you see this called summation x over n. When they say summation, summation it means addition. When you're summing every value of what? X over the count of that number. Here, from the formula, we say where x is what? Observation. Where n is what? Number of terms. Where x is what? Observation. Where n is what? Number of terms. Now let's look at an example of what we're saying about mean. For example, we have a table that has to do with cars, mileage, and cylinder. Now, what are we trying to find? We want to find the mean of the mileage. And when we say mileage, mileage is just talking about the distance a car actually traveled. So if you say, oh, what is the distance the car is covering? It's just what they mean by mileage. So now we have this kind of cars, and these cars here now we're asked to find the average distance of these cars. So what did I have to do? I have to just take their mileage and find their what? Their average. And what do I do? The mean equals what? The sum of all the terms divided by what? Total number of terms. When you hear the word mean, when you hear the word average, we're still talking about the same thing. And what do I have to do? Add them together, which is the 21.3, 20.8, and 19. I divide them by what? 3. I'm getting to have what? 61.1 divided by 3. When I divide 61.1 divided by 3, I get to understand that the mean is what? 20.366. Now, it is now left for me now to now say, oh, If the mean can be 20.366, it means that the average distance that the cars have traveled is what? 20.366, which means that these cars can travel for about 20.37 approximately, because I'm talking about 20.36. When I approximate it, it becomes 20.37. It means these cars can travel about 20.37 kilometer on 1 liter of fuel, because I tend to say that, oh, if the distance this thing can carry, then this distance that these cars can cover, it means that that's the average distance they can cover for a particular place is what? Is 20.37. Now, what do I mean by that? It's just saying that when we are asked to find the average distance these cars can travel, all we just need to call upon, or the function we need to call upon, is just what? Mean. And when we call upon mean help us do what? Find the average. And guess what? We have gotten the central location of what we are of the mileage we have, due to the understanding that we know that central tendency is to help us find what? The location of the point, data point, just the central location. And that's what they do. That's why they are referred to as what? Measures of what? Central tendency. The next function we're going to be looking at is going to be mean. Next function we're going to be looking at is going to be median. Next function we're going to be looking at is going to be median. What is median? We say median is the value, or median is the value that is the middle value. So the middle value is the median when the data set is what? Ordered. So for us to perform median on a particular data set, we need to do what? Order the data. So when you are asked to find median, you need to make sure when you get your data, okay, I need to make sure I order it. So for example, I have an Excel file and I want to find the median of a particular column. Now I get to sort that particular column in ascending order. So when I sort that particular column in ascending order, it is now expected of me to now put in my formula to find my what? To find my mean. It helps me to put in my formula to find my median. To find my median. So how do you find median? The first thing you need to do is order the data sets. And if we order the data set and we see that the values, the count of the values that we have ordered is odd, take the middle one. So for example, I have 1 to 5. 1 to 5, odd. 1, 2, 3, 4, 5. Now, the middle of 1, 2, 3, 4, 5. What's the value there in the middle? It's 3, because that value, the count, the values I just mentioned now are what? They are odd, which is 5. Now, in the middle of the 5 numbers I just mentioned, which is 1, 2, 3, 4, 5, we have what? 3 to be the what? The middle value, which is going to be our what? Median, due to the fact that the value stated are what? Odd. But when we have the values to be even, in terms of maybe I have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 now, 5, 6 now is now going to give me that ability to take the middle number of 1, 2, 3, 4, 5, 6, which is going to be what? 3 and 4. 3 and 4, because I'm going to have my 1, 2 staying and 5, 6 staying. Then in the middle of them, we have 3 and 4. What do I do? I add both of them together and I take their average. Now, when I add 3 and 4 together, it is 7. When I divide 7 by 2, I'm going to be having what? 3.5. At this stage, the median for me there is what? 3.5. That's what media is going to do. That's what the median is going to do. That's what median is going to do. And if you could see, we have our formula to be here. We have our formula to be here. Now, let's look at this example. Now, same table from the main table that we used. So now we want to find the median of the mileage. And you can see I had to arrange in ascending order, where I got to have the 19 come first, the 20.8 come second, and the 21.3 come what? Third. And guess what? It was easy for me to just pick up my median, because I know they are odd, so I don't need to start adding them together or adding the middle together. I just pick the middle value, which is what? 20.8. The median is the middle value, which is 20.8. Now, this is telling me that this is the middle value where the mileage are arranged in orders. So when this mileage are arranged in orders now, it's now expected for me to know that 20.8 is where we have, 20.8 is where we have that middle, is the middle value for the mileage, whereas the values that are above the 20.8 and below the 20.8 now tells us that the ones that are above is like telling us that it represents a typical fuel efficiency. We're talking about this interpretation of this 20.8 we've got now says it represents a typical fuel efficiency for this group of car, with half of the car having what higher efficiencies, and what half of the um having and half of it having what lower efficiency. So from 20.8 above, if I take 20.8 and I look upward and I go up, I'm saying that half of those ones have what higher efficiencies, but from 20.8 below they have what lower efficiency. So the median has been able to make me understand that the values that are above 20.8 are having what a typical higher fuel efficiencies, but when the values that are below 20.8 now are what having lower what fuel efficiency. With the use of median, I've been able to find a way to what get an interpretation of the question I'm trying to answer from this particular table. Let's move on. Mode. When you talk about mode, what are we trying to say? Mode is the most frequent occurring value in a data set. Note, a data set can have one mode, multiple modes, or no modes. So what we're saying is what number is occurring frequently, like which one is occurring more. So for example, if you look at this example we have here, we have 2, 3, 4, 2, 4, 6, 4, 7, 7, 4, 2, 4. Now we need to find that value that is what occurring the most. And what if we count it, the value that is occurring the most is 4. How many times did it occur? It's occurring 3 times more than the rest of the value there. That tells us that the mode is what? 4. That tells us that the mode is what? 4. So now from where we've started, we've been able to see what mean is all about. We've been able to see what median is all about, and we have been able to see what mode is all about. Now, let's move on to see when to use these measures. When to use these measures. When you talk about mean, you use it when the data is symmetrically distributed. When the data is symmetrically distributed, yeah, for knowledge purpose, what do we mean by symmetrically distributed or symmetrical distribution? Well, symmetrical distribution is when, is one when we have the left and the right side of the distribution being like they're like mirrors. When something is symmetrical, means you can find this thing on the left hand side and it's the same thing as that of the right hand side. So when I say something is symmetrical to each other, they are like opposite in the same way, that they are the same thing to each other. So when you have the right side of a particular distribution and you have the left side of a particular distribution, it's like saying what you are seeing on this left hand side is what you are seeing on the right hand side. But you might just the way it might be positioned might not just be the same, but they are still the same thing. It's like a reflection when you say something is symmetrically what distributed. So for example, there are some things we need to understand and we need to know when it comes to something being symmetrically distributed. So for example, when a data is symmetrically distributed, the mean, the median, and the mode they get to be equal or they are very close to each other. They get to be equal or they are very close to each other. And sometimes you need to understand that there's an a particular the values of the mean, the median and the mode are what? They are equal, and you can get to see that they are equal on both sides of the center data. So for example, by the time you find the mean, by the time you find the median, and by the time you find the mode, and you get to see that they are very close. They are very close. That's telling you that this data set is what symmetrical, and it is normally distributed. I don't know if you get what I'm saying. So when do you tend to want to use mean? When the data is what symmetrically distributed, and when it is continuous, when you have a continuous data. When you have a continuous data. So when you have a continuous data, you're trying to say that, for example, from the last class we had, we were able to see that we had some data, that some types of data type. When we talk about discrete and continuous, I could remember when we were talking about how the data types fall into. We said we have quantitative and qualitative, and under quantitative we have continuous and what and discrete. Now under qualitative we have it to be what categorical. Now we now said that even under that quantitative, the continuous and discrete, under it we have something to be called what ratioed and what interval scaled. ratio and what? Interval scaled. Now, from the qualitative, we're talking about, we say it's just you being able to what? Categorize things. And under them, we have what? The nominal and the ordinal. And we're able to get the differences between them from our first section. Now, so when we are saying a continuous data, you're talking about the continuous data that can, it's something that can take any value. When you say discrete, it's a whole number. But when we talk about continuous data, this is where you begin to have decimal values. When you have values that are no, that can be divided into smaller units, but they are not whole. So it is measured, it's not counted. And when you say why can we use mean there is because, for example, if you are told that we should find um, a way to use mean on the continuous data, it is easy for us to say that, oh, we can use mean on a particular continuous data to see how we can measure the temperature of a particular place. To see how we can measure the temperature of a particular place. So, for example, when you're talking about mean, you should get to understand that you can use it when you have continuous data to find what you are going to get from the middle. Because when you make calculations of it, it allows you to get precise calculation and comparisons. So when you want to compare two, it's easy for you to use a continuous data, for you to use mean in a continuous data to get what you're trying to figure out as the central location. So for instance, if you are trying to measure the daily temperature of a particular city, it is up to you to say, oh, what if we find the mean temperature for over a month? Because obviously, when you're talking about temperature of a particular place, it's not just in a whole number, a discrete value, it's a continuous value. I don't know if you get what I'm saying. So when we are using mean, or when you want to use mean, you should get to use mean when the data is symmetrically distributed. Another example we can look at when we're talking about symmetrically distributed is saying, for example, if we want to get the height of the humans or adult humans in a large population. So for us to do that, we can use the mean height to say, oh, this would be a very good representation for us in terms of height when we get the adult height and say, okay, we want every adult height in the population to come. We want to find the mean height, and when we find the mean height, we can use that to say we want to use it to what? Represent the mean height for that particular population. So getting to understand that we can use mean, in some particular form would be able to give us accurate answers, because we already know that, oh, we need to make sure we check that our data is what? Symmetrically distributed, which is normal, by checking out some other stuffs that are needed for us to know that it is symmetrically distributed, and for us to know that continuous data we can get to use what? Mean. But we're talking about, now let's move to median. When we talk about median, when do you get to use it? When there are outliers. Yes, for example, most times when we want to find outliers, we get to find outliers. And I can remember, I think in the first section or one other class, when we talk about outliers, we're saying outliers are those kind of information. They are like data points that are significantly different from every other observation in a data set. So in a data set, I have 1 to 10, and the next two numbers after that 10 is like 200, 300. They are so different from what we have. So they would influence whatever answers we are going to get from a particular analysis. But then how do we treat them? How do we remove them? This is where median comes in. Normally, most times we get to hear that we use mean, but when you use mean, sometimes you might not be able to, find out, you might not be able to get out the outliers. You might not be able to replace, because when you find outliers, you need to remove them. And when you remove them, how do you get to replace those outliers? Now, median is what comes to help for us. Median is what comes to rescue for us, that, oh, okay, I am here, use me to find what? To block in the outlier. So for example, I have a value of 30, 35, 40, 45, 50, then I have 1000. From these values I just mentioned is to tell you that 1000 is an outlier, because the difference is just far from what I've mentioned. But then I say, okay, for me to now get to solve this problem, because I already understand that there's an outlier, I find the mean. By the time I find the mean of these particular values, approximately it's going to be like 200. So when I remove the outlier and I replace it with the 200, it's still high, because the values I have mentioned are 30, 35, 40, 45, 50. So if I replace 1000 with 200, it's still high. But when I use median, I arrange them in an ascending order. And after arranging them in an ascending order, I get to pick the middle value. But when I pick the middle value now, it's easy for me to now replace that outlier with the middle value. That is when median come into what? Into play, to help us solve the issues of what outliers. I don't know if you get what I just said. So when we get to understand where to use this thing, they come this formulas, they come very very good in handy for us. We say for skill distribution, we are talking about skill distribution. A skill distribution is an asymmetric and has a longer tail. So when you're talking about something being skewed, it's either you have it right skewed or you have it left skewed. So when something is rightly skewed, you find them to extend to the further right. When something is leftly skewed, you find them to extend to a further left. That is, it's just on a side. You just get to pick up a particular data set and you see that they are falling in a particular side of that data based on how they are skewed. So median can come in handy to help us, solve that issue and for us to know that, oh, this data set we have access to is what is skewed. How can we get to find a way to make it balanced for us to be normally for it to be normally distributed, for us to what work on it? Then that's when you get to understand that there's something called right skewed, left skewed, and what symmetric. I'm not supposed to speak about this section, but then just for us to understand why we when we get to use all these measures. So, for example, there are some things we need to know, that there's a relationship between mean and median. When a mean is greater than the median, we should know that that data set is what is rightly skewed. When a mean is greater than that median, but when the mean is lesser than the median, you should know that it is what leftly what skewed. But when the mean is equals to the median, you should know that that data set is what symmetrically what distributed. And also when we talk about mode, we say for categorical data, and when we want to use it, we get to use it for categorical data and to find most of the what common values. So when we talk about mean median mode, this is how they come to help us in what getting to solve some problems that we are encountering with what the data set we have access to. And we can use them to what help us get out some things that would disturb our data from what helping us get a data driven information from it. Moving on, measure of dispersion. Measure of dispersion. When we talk about measure of dispersion, it's the same thing as what? Measure of variability. We have it to be called measure of dispersion, and we also have it to be called what? Measures of what? Variability. So when we say measure of variability, what do we mean? They are also what? 10 are measures of what? Dispersion. They help us to gain insight about the dispersion or the spread of the observations at hand. What do we mean by the observations at hand? We're talking about the data set we have access to. So when we want to know how these things spread out, then measures of dispersions are the ones that help us do these things. And for sure, we just say measure of dispersion tells us how spread out our data is. It tells us how spread out our what? Our data is. And the main measures of dispersion that we have is we have range, we have variance, we have standard deviation, and we have interquartile ranges. Range, variance, standard deviation, and interquartile range. Now let's look at range and see what we are talking about. Range. When we say range is what the difference between a maximum and a what and a minimum value. A maximum and a minimum value. So now in a data set, so now for me to solve to find the range, all I need to do is find the maximum value. If we remember, we have functions that help us find these values in whatever tool we want to use. We find the maximum value, find the minimum value. For example, I have 2, 4, 6, 8, 10 in this particular slide, and I said what's the maximum value there? We have it to be 10. The minimum value there, we have it to be what? 2. Subtract it from each other, we have what? 8. So now one of the key points about range is that it's easy to calculate and understand, and it gives us a quick idea of how our data is what is spread out. But then it's not something that we get to use on a complex data, because it might not be able to give us that um right value we want in order for us to get how spread out our data is. But then range is very good, to help us what get a quick idea of how spread out our what data is. So for example, when I get a big data, I have a big data set, I just get the maximum and the minimum. Yeah, I get to see that, oh, this is how spread out this is, but it won't go deep to give me what I want as that of the variance and the standard deviation. So from there now we'll be able to look at what variance is all about. When we're talking about variance, what is variance? We say variance is defined as an average squared deviation from the mean. It's defined as an average square deviation from the what? From the mean. It is calculated by finding the difference between every data point and the average, which is also known as the what? The mean. Squaring them, adding all of them together, and then what? Dividing by the number of data points present in our data set. That's what we have here. From our last section, I think I was able to speak about sample and data and population. We spoke about sample and population. Said population, a group of individuals in a particular place. When we're talking about population, the sample is just having access to just representative data. When you have access to just representative samples, and these samples are what you just use to like make decisions that would influence that would be able to give you that decision you will need to use on a particular population. So from this formula now, we have it to be summation open bracket x minus x bar or close bracket raised to power 2 over n minus 1. There's some places you see this formula and you are seeing over n. Why? That one is you when you're trying to use it in terms of population, but we're trying to use it in terms of samples, because every data set we get to have access to are samples and not just the whole populations. Now, you will now be able to see that from here, you see that I said where x is what? The observation under consideration, and n is the what? The number of them. Why bar x is the what? Mean. There are some places you see it as mu. There's some places you see this bar x as mu. It's the same thing as what? The mean. So now, when we get to find this variance now, we would be able to see an example of how variance influences whatever we want to know, work on in a particular data set. Let's see. Look at this particular example. So we have a data of our monthly sales data. We just have these values, but then we represent them in thousands of dollars. So for example, you're having that 45 to be 45,000, 52, but then we're working with it as what? Just the value. Now, for the first month, the monthly sale we had was 45,000. Second month, you can see all the way. Now, we were able to use it to do what? To find that the first month we had, this is January, this is what we were able to figure out, down to the 12th month, which is December. This is what we were able to figure out as our what? As our sales. Now, the next thing we had to do was to do what? Find We want to find the variance, and from the formula, if you could remember, it is what? Summation open bracket x minus x bar or close bracket raised to power 2 over n minus 1. Now, we have to pick those values small, one after the other. So the first thing we need to look out for is what? X minus x bar. And x minus x bar is what? We need to find x bar. What is x bar? X bar is just saying these sales that I have here, bar x, these sales that I have here from 45 to 51, I have the sum. This is the sum here, which is what? 595. When you divide this sum by 12, you'll be able to have your mean. When you divide that sum by 12, you'll be able to have your what? Mean. All we used to find mean is just the sum of these sales divided by the number of observation, which is what? 595 divided by 12. Now, I had to do this now. When I do 595 divided by 12, I'll be able to get 49.5 dime or something. So now 45 point it's 45 or 49 point um 95. So now when I have that now, it's easy for me to now see that subtract this. So yes, to confirm that when you divide this whole sales by 12, you should be able to have it to be 49.5. Yes, 49.58. 49.58. Why? How did I get to know that? Because I can see that my x minus my mean is giving me minus 4.58. So obviously my mean is what? 45.58. Now, x minus by x is what you are seeing, that the first sales 45 minus 49.58 is giving me what? Minus 45.58. Now, the same thing I have to do all the way down to get this. Now, every subtraction of a particular observation from the mean, when you do the summation, when you add it all together, it's going to give you 0. Theoretically, every whatever you're trying to look for, where standard deviation, the moment you're having x minus bar x, whether regression analysis of some formulas that you can find x minus bar x, always know that the sum of all the values will give you 0. But in this case, the reason we're having 0.04 is because of the approximation we've done to some of these numbers that are here. So that's why we are seeing 0.04. Because when we get to what? Approximate, we still get to find it to be what? 0. Now, after doing that, we find the square of x minus x bar, which is what you are seeing on this right hand side. When you find the square of this, you're going to have it to be 20.97, all through like that, just the way you are saying it. From square of this one gives us this, square of 2.42 gives us this, all from beginning to the end. Now, after doing that, we have the what? The sum. So you can see the sum is what? Which is from here, you can see from here, the sum is what? 60.95. Now, we've been able to find the upper part of what? of the variance formula which I mentioned here. So now this summation x minus x bar x all square is what we have to be what? 60.95. Now we will just divide it by the what? Number of observation minus 1. So now when you come here now, look at it, same formula. We said variance is what? Summation x minus x bar square all over n minus 1. Now we've gotten 60.95 to be our what? This upper side divided by 12 minus 1, which give us what? 5.54. Now this is telling us that the variance of our monthly sale is what? 5.54 thousand dollar squared. Dollar squared. Now most of the time when we want to find out how our data is spread out from its average, we get to want to use standard deviation. But first, before you find that standard deviation, you need to find variance, because the square root of your variance will give you your what? Your standard deviation. Most time we don't tend to want to rush into use variance, but then if you can get your variance, obviously you'll be able to get your what? Standard deviation. Now this is telling you that the variance, or how spread out, or how, in terms of variance of our monthly sale, is what? 5.54. Now let's get to the part that this begins, like where it begins to make sense in terms of us finding what? The standard deviation. Now standard deviation, if you could see the formula I have in this diagram, it's the same thing as that of the variance, which is the square root of what? Summation open bracket x minus bar x or close bracket raised to the power 2 over n minus 1 or square root. Now we need to find s. That's the s, the standard deviation. That is what is going to now give us that answer to how spread out our what? Our data is from the average. Now standard deviation, we said, is what? It is defined as the square root of the variance. It is calculated by finding the mean, then subtracting each number from the what? From the mean, which is also known as the average, and the squaring the what? The result. Adding all the values and then dividing by the number of terms followed by the what? The square root. Just as the formula of variance, the only difference between standard deviation and variance is that variance is like the square of that formula. Standard deviation is the square root. Standard deviation is the square root. So now, same data set that we have, which is what we did from the last time when we did all this for the variance. This is the same table from the variance. And it's easy for us to just move now and say, we know from our variance we got what? 5.54. We find the square root. Now finding the square root of 5.54 will give us what? 2.35. 2.35. That means that the standard deviation is what? 2.35, and instantly it has been able to tell us that on average our monthly sales deviate from the mean by what? About $2,350. You know, if you could remember from the data set we have, this from this I told us that we should represent this value and know that it's in forms of what? The dollar. Now from what? On average the monthly sale deviates from the mean by what? 2 point $2,350, which is 2.35. Now we know what the average is, which is what we said about 49.58. So now it means that on every month, so for example, let's come back to this table. Look at this month now. We have what? 45. Don't forget our mean is what? 49.58. 49.58. So standard deviation help us to tell us that, oh, from these sales you have this month, there's every tendency that when you know the average of the monthly sale we've had, it means that it's telling us that from every average sales we've had for the months that we've calculated, that each of the months they deviate, or they get to increase either by $2,350 or they reduce by $2,350 from the average. That's what they are trying to say. Yeah, it means on average the monthly sales deviate from the mean. Deviating from the mean means by either it is by adding or by subtracting to that mean. So now, for us to do that, for us to be able to get that now, is for us to understand what standard deviation is doing, telling us how spread out our data is from the average. So now with this, now I've been able to figure out that, oh, when I find the standard deviation of this monthly sales we've had, it's telling us that every the monthly sales calculation we've had is that every sale we've had from the for each month are just different from the average monthly sales that we've calculated by $2,350. Now let's come to the table. Now look at this. If you see this now, this is what 45 point, and this is 45, and we said the average sales for the month is what 49.58. If you subtract this from 49.58, you see that it's giving you this, which is 4 point what 58. So now, what is he trying to say is that when we get to subtract, it's to help us in terms of saying that the difference between what we're going to sell for that particular month, based on the average we've gotten for some months we've sold, will just be 2.35, which is what is giving us in this place. So standard deviation help us find how a particular value deviates from the mean. So that's why you see they call them the measures of what? Dispersion. Measures of dispersion. Now, moving on, we look at something called interquartile range. What do we mean by interquartile range? This is us finding the range of the middle, 50% of the data. When we want to find the 50% of a particular data, what's the range like? What's the range like? And how do we get to calculate this? We need to make sure we order the data sets. And the first thing we need to find the quarter one, that's first quartiles, which is 25 percentile, the third quartiles, which is what 75 percentile, and the interquartile range is not the 75 percentile from the what the 25 percentile, which is Q3 minus Q1. Using that particular table too, we get to use this monthly sales data. And the first thing we did was to do what? To sort it. Now, after sorting it, we now split it into lower half and what? Upper half. Lower half and what? Upper half. Because this method is what we want to use to find what? The Q1 and Q3. Normally, sometimes, most times we get to use and find Q1 and Q2, that probably from when we draw the graph, then we find the Q1 and Q2, then go to the graph to go and find this, then we'll say, oh, this, and using some particular formula to get that. But in this form, we can divide the data set into two halves. We have the first half and the second half, then we pick the middle of those numbers. So for example, if you look at this, we have the Q1 to be 25, so we pick the average of the two middle number in the lower half, and we pick the two number in the middle of average. We find the average of the two middle number in the what upper half, and when we found that, we have to subtract from each other, and when we subtract it, we have what 3.5, in terms of saying that when we want to represent it in dollar, we're saying $3,500. Now, what is this trying to tell us is that it's trying to tell us that the 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 range of these sales, from half of it, is just having a difference of $3,000, $3,500 from themselves in the middle. Because when we said interquartile, we were talking about the middle, the 50% of what? Of a particular data set, the range. So it means that half of the month had sales figures with about $3,500 ranges of what? Each other, afterwards sorting it. Now, how do we get to figure that out? So let's look at this. If we're getting to see the middle of how it has been arranged, we'll be able to figure out that from each others, if you look at this now from middle, if you say this 51 from the minus 48, you'll be able to see that 51 from 48 will give you what? 3. 52 from 48 will give you 4. 52 from 49 will give you 3. 53 from 49 will give you 4. So you will see that with these formulas and with these models, we'll be able to find whatever information we need to know about a particular data in terms of say central tendency and how they are what how they are spread out. Conclusion: understanding these descriptive statistics allows data analysts to do what? To summarize large data sets concisely, identify patterns and trends, make informed decisions based on data characteristics, and communicate findings effectively to what? To stakeholders. Help us communicate findings effectively to what? To stakeholders. And now, after doing that, I've been given an assignment to do what? Find the mean, the media, the mode, the range, the variance, standard deviation, and the interquartile range from a data set that will be given to you, and write a good report giving a proper interpretation of your what? Of your finding. At this stage, we're already done with the class and we've been able to see what mean media mode and range variance, standard deviation, and interquartile range is all about and what they can do. Now we will get to do that on our own to by ourselves and see how we can find them from the data set I'm going to be sending to the group chat. And what do I mean by giving a proper report? Now, for example, I have this particular report here that says that, for example, I was told to find the mean, standard deviation, the quartiles, and I wrote down the means of what they told me to do. So from here, they want me to find the ages, the number of people, the number of children, number of adults. I was able to do all of that. Now, and I got to give a proper what? A proper interpretation of what this is saying that the average mean is 49.9 with the standard deviation of what? 18. So when I mean proper giving proper interpretation of your finding is for you to do what? Find all these um information using the main media mode and the rest, and do what, and give a proper report of how you what got to find and what those values are doing, or what those values get to do with data sets we have. So from there, we have been able to come to the end of today's class. I've been able to come to the end of today's class.